In this video, we're going to look at rational inequalities. So if we recall what a rational number is, it's a fraction. So as you can see here, we have two linear equations in fractional form. So we're asked to solve x minus 8 over x plus 2 greater than minus 1. Now we're told that x does not equal minus 2. If x did equal minus 2, well then this would be 0. So it would be undefined. And we're told that x is an element of real numbers. So let's solve. First step is we want to bring everything over to one side and have 0 on the other side. So if we have x minus 8 all over x plus 2, when we bring this minus over, it becomes plus 1 greater than 0. That's step 1. Step 2, we simplify this so that it's just one fraction. So we're looking for the lowest common denominator. Now if we rewrite 1, we can write 1 as 1 over 1 so that we have a denominator. So the lowest common denominator will be x plus 2. So we have x plus 2 as the denominator. The numerator then, so we have x plus 2 divided into x plus 2 gives you just 1. So it's going to be 1 times x minus 8, which will just stay as itself. So x minus 8. 1 into x plus 2 will be x plus 2. So then we're just multiplying 1 by x plus 2, which again will just give us x plus 2. And that's all greater than 0. We need to simplify this numerator. So if we simplify it, we have x plus x, which gives me 2x, minus 8 plus 2, which gives me minus 6. And then we have x plus 2. And that's all greater than 0. At this point then we call this our test box. Okay, and then we solve. So we look at the numerator. So we say that that's 2x minus 6 equals 0. Or we have the denominator, which is x plus 2 equals 0. So 2x minus 6 equals 0. So then x would be equal to 3. And in this one, x plus 2 equals 0. So then x would be equal to minus 2. At this point, we don't know what our solution set is. So if we recall how we do it when we looked at quadratic inequalities, we use our test region. So we have our two values. So x equals minus 2 and x equals 3. So what we're doing is we're testing values. So the first region is we test any values that are less than minus 2. Our second region is this middle region. So we test for values that lie between minus 2 and 3. And the last part we check is for values greater than 3. So pick any value that's less than minus 2. So if we pick x equals minus 3, it's less than minus 2. And we look at our test box, we sub this value into our test box, and if we find that the inequality works, well then we say that this will be our part of our solution set. So if we sub 3 into our solution set, we have 2 times minus 3 minus 6 all over minus 3 plus 2 greater than 0. So we're testing it. So 2 minus 3 is minus 6. Minus 6 minus 6 is minus 12. And then at the bottom, minus 3 plus 2 gives me minus 1. Minus 12 divided by minus 1 is 12. So that's greater than 0. So that particular solution works. So we know then our solution set will lie less than minus 2. So any value less than minus 2 will work. Then we want to test this particular region here. So we pick any value between minus 2 and 3. So the easiest one to pick is when x equals 0. And again, we sub it into our test box. So we have 2 times 0 minus 6 all over 0 plus 2. And we check, is this greater than 0? Well, 2 times 0 is 0. That's going to be minus 6 over 2. Well, minus 6 divided by 2 is going to be minus 3. Minus 3 is not less than 0. So our solution set will not lie between minus 2 and 3. The last region we want to check is for any value greater than 3. So if we just pick x equals 4 and again sub it into our test box. So 2 times 4 minus 6 all over 4 plus 2. And check to see is that greater than 0. So we have 2 times 4, which is 8. 8 minus 6 is 2 over 4 plus 2, which is 6. 2, 6 is greater than 0. So that solution also works. We know then that our other solution set is any value greater than 3. So our solution set, if we put both inequalities together, is that x is going to be less than minus 2 or greater than 3. And that x is an element of real numbers. So it will be any value that lies in between, well, not in between, any value that's greater than 3 and any value that's less than minus 2. So just for argument's sake, if you were asked to plot that on a number line, okay, so we'll have 0, minus 1, minus 2, minus 3, and so on. And then here we'd have 1, 2, 3, 4, 5, and so on. So we know it's greater than 0, so it's not 0, so we put an open circle at 0, and then it's greater than it, so we will be shading in all of these. So for any value greater than 3 will work for our particular inequality. If we look at the number line and we look at the minus 2, so it's less than minus 2, so that means minus 2 is not included, so we have an open circle, and then we'll shade in everything less than minus 2. So again, our inequality will work for any value that's less than minus 2.